Okay, so we are going to review some KCNA questions this morning. So before I do that, I probably want to talk a little bit about the KCNA exam for just a minute. Let me pull my questions over just to make sure that I am all set with that. Of course, where are they? Yeah, there they are. Okay, we're going to go over some questions. But first, hi, I'm Michael Forrester. I'm with KodeKloud. I am one of the principal trainers, and despite my lack of ability to get into community stage and apparently my slight disorganization this morning as we switch gears, I am one of the principal trainers and do a lot of the courses that you take over at KodeKloud. I am one of the primary curriculum designers. So let's talk about KCNA because we've had this big kind of Kubsternaut push, as you've kind of been aware, because the CNCF has had a Kubsternaut push. So we have just kind of been supporting them in that whole process. So what we're going to do today is we're going to go through some of the KCNA questions, go through some of the reasoning and whatever. I will mention is that KCNA is probably one of the newer exams that has come out that is part of the suite of kind of Kubernetes and CNCF certifications. So, CKA, CKAD, so Certified Kubernetes Administrator, Certified Kubernetes Application Developer, Certified Kubernetes Security Specialist, which is the CKS, and the KCSA, which is similar to the KCNA in that it's basically about the third party and primary party landscape of security as it relates to the CNCF and particularly to Kubernetes. So the KCNA is basically something that they added so that you could figure out how to get into the ecosystem of the CNCF. So this is really designed ideally for people who are just beginning their journey into the CNCF, into Kubernetes. And as you can see here, obviously this is the Cloud Native CNCF certification, so the Cloud Native Computing Foundation, but it's actually hosted by the Linux Foundation. And you'll see that it's $250 USD usually, right? If you want the course, it's an extra $49. And you get 12 months to take the exam, 2 attempts. There's an exam preparation handbook which you can look at, which actually we could look at. And this basically is just going to run through the generics of taking an exam with the Linux Foundation. But the main thing to be aware of is that this page right here, the domains and competencies, because there isn't really a kind of like good handbook that at least they publish on this. If we even look at the curriculum, right? If we look at the curriculum for the Exam Native, there is this great little resource that kind of breaks down what they want to cover, but it's the exact same thing that you can see right there on the homepage. So there's no, it's not super useful. Hold on just 1 second. Oddly enough, my headset is asking me to plug itself in. So this being said is that this gives a good breakdown for what's covered in the exam. And so what we're planning on doing is that this is week 1, so we're going to talk about Kubernetes fundamentals in terms of just covering questions related to that. And notice that it's 46% of the exam. So out of the full set of questions, 46% of them are going to be about Kubernetes fundamentals. So this is resources, APIs, containers, and scheduling, which you see here. As you can see the breakdown for the rest, there's container orchestration, there's cloud native architecture, and then the last 2 are cloud native observability, which is basically monitoring, logging, and tracing, and then cloud native application delivery, which is really just about CI/CD pipelines, GitOps, application stuff.
Sorry, Michael, are you sharing screen? Sorry.
Oh, yes, I am.
Yeah.
Is it not? Is
I
it
can.
showing?
No, I cannot see.
Huh. It shows that you can see my screen. Let's try
I can see yours, like you, like
Oh,
and not the screen.
oh. Maybe I shared the wrong screen. Let's try this again. There we go. How about now?
Yes, now I can see. Thank you.
Awesome. Okay. Good. So, thank you for saying something. So, this particular URL, which yeah, we'll probably hold on to that for a second. But you can easily find this in Google. Just search for KCNA Linux Foundation. This is where all the information is at, and there isn't a lot of it. So, other than the domain competencies and breakdowns, as I just pointed out, there's no difference between what's in the PDF files for the supposed study guide versus what's on the website. So like right here, like they have a handbook that didn't have anything in it. They have other resources here at the bottom. For example, the curriculum overview. There's nothing new in there. Everything that you would need is right here on the homepage. Now I say that, obviously, if you've taken Azure or AWS or Google, there's a lot more in their handbooks about the exam than what you see here. So again, 46% is Kubernetes fundamentals, a little less than 25 is container orchestration, a little less than a 6, well, actually a 6 is cloud native architecture. And the remaining 6, of the exam, 1/6 of the exam is cloud native observability and application delivery. So what we're going to do is we're just going to spend some time focusing on Kubernetes fundamentals, and then next week we're going to do some container orchestration. Next week, week 3, we're going to do some cloud native architecture, and then we're going to talk about observability and application delivery. Now, the whole idea of doing this series is to just give you a feel for the level of questions that you're going to get in the exam, because if you are remotely experienced with Kubernetes and the CNCF, you're going to be shocked at how easy a lot of the questions are. And sometimes there's really hard questions thrown in there. So before I go forward into the actual question review, are there any questions about the exam itself? Anything that we should talk about before we move forward? No? Okay. Let's see. I think the only other question that I am frequently asked is how many questions are on the exam, because it doesn't actually say. Now, having taken it just recently, so I wanted to make sure I had the experience. It is a 90-minute exam, and I believe there's 65 questions. So oddly enough, you end up with very little time to actually digest the questions. Like you end up with about 1 minute and 30 seconds for, give or take, about per question. So let's talk about the questions themselves. Okay. So this is a sampling. This is not what we're actually going to go over. But this is like a sample of the kinds of questions that you'll see, like which Kubernetes object is used to expose a set of pods as a networking service, right? And so what we're going to do is we're going to talk about what that might be. Now, obviously, in this case, you can see the answer, right? But this is the general format for how we're going to review. The only difference is that you're not going to see this answer right away. We're going to give it a second. Let me just make sure to see. Flamin', I see you there. Thank you for saying something. I just opened chat. All right, here's the URL for the cloud native thing. So like here in this particular case, which object is used to expose a set of pods? Well, anything using the words expose kind of like triggers you right away is that it's probably going to be a service, because that's literally the command, right? And so a service in Kubernetes provides obviously a stable entry point, right? And sometimes, by the way, the services are private to the cluster, like the cluster IP, and obviously many times they're external, right? And so that's really what a service does. And so, for example, it'll go through and we'll talk about why, for example, a deployment is not the right answer, config maps, what they do. And so, oddly enough, even just through these kinds of exams, which is typically how our mock exams are structured, you can learn the material in many cases just by going through the exams, especially if there's gaps in your knowledge. So here's what we're going to do, is that we're going to take a run at domain 1. Okay. So this is domain 1. This is 46% of the exam. So you're going to get about 20 questions in this particular case, which actually seems a little light, but I think I might have limited it to 20 questions instead of doing the full weighting. I think in the actual exam, it ends up being about 30 questions, like a lot more than you think about Kubernetes fundamentals, right? So we're going to play a little game. The game is this, is that what's the primary function of a pod? And then you're going to read the answers. I'm going to give you about a minute or so, and you're just going to put your answer in the chat, like whatever you think it is, right? So if the question is, what is the primary function of a pod? What is the answer that we think? Run one or more containers that share storage and networking? network access for different clusters, configuration data, or manage user authentication. So this one seems pretty straightforward, right? Definitely seems like C is the right answer because, you know, a pod is the basic unit of deployment inside of Kubernetes. A pod can contain one or more containers, usually primarily an application container and possible sidecars. And so this is pretty much a gimme question, right? The answer is C, right? And the correct answer is C. Oops, assuming that I don't want to actually cut it out of my document. And so there it is. And of course, the other options should be kind of self-evident if you know anything about Kubernetes objects, right? As far as network access and authentication. Although I will tell you that it always shocked me the first time I learned that Kubernetes doesn't really have, in a sense, like an external authentication, like a user-based system. It's actually like certificate-based. It always threw me for a loop that like user authentication externally was usually certificate-based unless you federated. So it always threw me for a loop. We usually can will put references to our right answers just to like provide justification. This PDF, by the way, I'm going to literally just pop in the chat. Like I'm going to put domain 1 out there so people can self-study if they want to. Okay. Let me just check one thing because... oh, no, that's something unrelated. Okay. So let's talk about question 2 then. Which Kubernetes resource would you use to ensure that exactly 3 replicas of your application are always running? Now, that might seem like a tricksy question, but the answer is, if you know anything about Kubernetes, it's pretty straightforward. Now, I will tell you this, is that it always cracks me up because you're like a little bit like, really? These are the questions? And so many people get CKA and they don't go after KCNA, but like if you've passed CKA, you probably have 80% of the knowledge to like pass this in question, right? So yeah. So in this particular case, it probably wouldn't be a pod, since a pod is the smallest deployable unit. And if you wanted 3 replicas, you'd probably have 3 pods, right? It probably wouldn't be a service, because a service is an object that acts as, in a sense, like a network entry point into a bunch of pods, right? Or deployment. And then you have a config map, which is just obviously what it says. It's not a secrets thing per se. It's used for configuration, right? So just by virtue of elimination alone, even if you didn't remember the workload types like deployments and stateful sets and you would probably know that a deployment could be the thing just by virtue of elimination. So, right? And so in this particular case, a deployment basically is a placeholder for a bundled like set of objects like replica sets and pods and whatnot. So so the idea here is that a deployment is the easiest way to get you to a kind of, in a sense, a group kind of deployment, which is what you're asking for when you ask for more replicas versus just doing a straight pod. So, all right, let's go on to question 3. So again, easy peasy. What type of information should be stored in a config map? Oddly enough, I just talked about that. Was stateful set in the options? So there was a question there. Was stateful sets in the options? No. And so that's obviously, Fleming, just to say this is probably why, if stateful sets had been in here, that would have been very confusing, because you could probably do that with stateful sets as well, right? So luckily it wasn't one of the options in the answers. They try to make it so that there's clearly only one answer. So they're pretty good about that. Having worked for various companies that do certifications, that would be very confusing. All right, so what should be stored in a config map? They make some interesting distinctions here. Database passwords and API keys. That seems like sensitive information, right? Container images and their versions. That doesn't make any sense. That's what a registry is for. Network routing information makes 0 sense, right? Maybe if it was like a network config map, if that was the name. But if you know anything about it, and I see, Flamin, that you put the answer, is that non-sensitive configuration data like environment variables, that would like make a lot of sense, right? So correct answer is indeed B, non-sensitive data configuration information. So this is what, you know, this would make sense. Again, hopefully if you've even touched Kubernetes, you would touch the config map at least once. If you touched a Helm chart, you certainly have touched the config map, because they usually are creating it as references. So there we go. All right, question 4. What component of the Kubernetes control panel stores all of the cluster data? Again, kind of a gimme, right? You feel like now you're like, wait, is this predominant questions on the exam? Because I feel like I could just like stone cold take that thing. Again, this is where if you're new to Kubernetes, so if you're new and you're struggling on this, great. Hopefully this is teaching you something. But basically, it's like which component of the Kubernetes control plane stores all the cluster data. So how does stateful persistence work for the cluster? Not necessarily for like pods and deployments and all that, for the containers. How do you create persistence for the cluster? Like what is the backing kind of data store configuration files? Like how does that work, right? So if you've ever deployed Kubernetes or certainly worked with one in production, probably would make sense that etcd would be the answer. And notice I said etcd. I believe that's a holdover because I've been saying etsy since I first learned Linux back in 1998. And because the etsy directory, so I think that's how etcd came about, right? I think that's where they probably got the name, is that it's etcd. So someone the other day asked me to phonetically write that down, and I just put the word Etsy from like at the Etsy website and then D-E-E. So that would probably be the answer, because if you look at the rest of these, like these are components, right? The API server obviously acts as an API receiver and redirector. The scheduler does exactly what you think it would do. It schedules, right? And the kubelet typically runs, I mean, it can't run on every, it does actually run on every object, every node in the cluster. And so it works with kubeproxy and or other elements if you replace them to basically enable Kubernetes functionality on the worker nodes. So it does things like checkpointing, receives scheduling commands, all that other stuff. So the correct answer here in this case would definitely be etcd. etcd has a lot of use cases well beyond just Kubernetes, but that is its number one use case by far, is that everybody just uses etcd for that. If you need to see something about components, just make sure for those who join us later, that's it. All right, let's move on to question 5. What's the difference between a container image and a running container? That's a good question, actually. I remember getting corrected on this in the early days of Kubernetes and containerization back in like 2013, 2014. 2014 actually would be the date. 2014, 2015. Because we actually had virtual machine images, and so every time they said image, it was kind of confusing. I was like, are we talking about virtual machine images? And then they were like, no, we're just talking about images. And it was kind of this interesting conversation of like, I was like, well, images have been around for a long time, so can we call them container images? And so now it's like everybody calls them container images. But when it first came out, people forgot that like we had, you know, snapshots of virtual machines that we called images or golden images or whatever, right? And so the difference here between a container image and a running image, like what do we think that might be? Let's see. Well, they're definitely not the same thing. Image is a template where a run container is an active instance of that image. Container images run applications. Container stores data. Okay. Container image is larger than a running container. So, what do we think the guess? What do we think the answer is here? It's pretty straightforward, right? If a container image contains basically the template for running everything, right? It's our deployable artifact, and a running container is the actual artifact deployed. So I say that an image is a template. That's a good way to talk about it. And an active instance of that image is actually the running container. So the answer would probably be B. Good. Okay. Let's go on to question 6. Which command would you use to view all the pods running in the current namespace that you're in? I mean, again, kind of a give me command if you've ever touched Kubernetes, right? So describing pods, creating pods, deleting pods, everything revolves around get. I'm not sure why they chose the get verb, but it's like we're going to get information about the objects. don't know why they didn't do like ls or ps or like you do with other, like Docker, for example, Docker ps. Although I think some people have added aliases for ls. Anyway, regardless, probably the answer is like B in this particular case. All right, here's a bonus ask. What would you run to get them in all namespaces, right? That would be an even deeper question, right? Or how would you specify a namespace? So in this case, the correct answer is definitely, we're just going to kubectl get pods, right? All right. Let's roll on to question 7. Question 7, we're still in Kubernetes fundamentals. What is the purpose, basically, of a namespace? Like, what is it used for? Does it provide persistent storage? Pretty sure that's not true. Logical isolation and organization of cluster resources? That sounds good. Manage container images? That doesn't sound right. Establish network connections between pods? That definitely doesn't sound right. So obviously I would say that B is the right answer because it's used basically for isolation and partitioning. So definitely the right answer there. The correct answer, I believe, would be B. Oh, I forgot to post the question. Let's try that again. All right. Next question. We're going to start going a little faster. What happens when you apply a YAML file using kubectl apply-f deployment.yaml, right? So here's an interesting kind of test. It only creates new resources and fails if they already exist. Interesting question. It creates new resources or updates existing ones to match the YAML specification. Cool. It deletes all existing resources and creates new ones. And it only validates the YAML syntax without making changes. So what do we think here? So obviously apply will take this -f file deployment YAML and it's going to ingest it. So it's going to ingest this deployment YAML. But what will it do exactly? Will it only create new resources and fail if they already exist? Will it create new resources or update existing ones to match the specification, delete, or will it validate? So pretty sure it won't delete because there's actually a delete command. It only validates the YAML syntax without making changes. That's not true. Otherwise, we wouldn't ask it. Excuse me, to apply. It only creates new resources and fails if they already exist. Or it creates new resources or updates the existing ones. I believe that the right answer is probably going to be B, right? It's actually going to create new resources if they don't exist. But if you're asking it to apply this file to this object, what you're actually saying is that no matter where the file is at now, if it doesn't exist, create the object. If the object exists, I want you to update the specs for that object to match this file, right? So it's a declarative approach, which it basically says, this file declares the state that I want this object to be in. And so I want you to apply it. And by the way, if the object doesn't exist, just go ahead and create it. But it's definitely not going to delete the object. It can overwrite an object. So it could possibly force a redeploy, for example, depending on what you changed. Okay. Let's talk about question 9. Which Kubernetes object would you use to expose your applications to other applications within the cluster? Okay. Now, this could have gotten really tricksy. They could have like put up here, you know, load balancer. They could have put up cluster IP. They could have put up node port. But, you know, obviously, if you like just wanted to expose applications to other applications within the cluster. So in this case, it's like, what would you use? Well, again, it's a pretty straightforward question because Deployments are used to deploy basically identical copies of applications at scale, right? Good for horizontal scaling. Config map, obviously, we talked about before because we had a previous question about it having configuration information. Secrets is kind of the ancillary of config map, right? Where you've got sensitive information, configuration information in there. So even by process of elimination, you're kind of left with service as the answer. So if we look down here, service is the natural option. Question 100. That's what I'm about to do is we're going to go over question 100. Okay. Any questions about any of that? Flamin', are you good? Yes? All right. What's the role of the Kube API server? Okay, so question 10, so we're on to the next one. What's the role of the Kube API server? Well, all right, let's talk about it. So in this particular case, the API server's name kind of gives it away a little bit, right? Because it's not the scheduler, right? It's not the controller manager. It's not the cloud controller manager, right? It's right. It's so, for example, to schedule pods on worker nodes. Okay. Well, that sounds like that would be the scheduler. To run containers on worker nodes, that sounds actually like that would be like the kubelet. To provide the API interface for all cluster operations, well, that sounds pretty straightforward. That sounds like what the API server would do. To store cluster configuration data, well, we talked earlier, we had an earlier question about how etcd was the actual persistent store, right? So in this particular case, I would say it's probably going to be C, right? Provide API interface for all cluster operations. Yeah, so and that, my friends, that moves us on to question 11. So you're probably getting a feel for the level of complexity of these questions, and it's not high, right? It's fairly basic. All right, let's talk about question 11. So how do you specify which container image to use in a pod? Okay, so this is an interesting challenge because we're starting a little bit to get into like the specs, like the breakdown of a YAML file. So is it in the metadata section of the pod specification? Maybe. If you don't know it, you might say, oh, it's in the metadata. But metadata is typically data about the data, so about the specification in this case, right? Is it a separate image spec resource? Maybe. It's in the label section? No. Labels are typically used for management and manipulation, not necessarily for specifying. Is it the spec container's image field of the pod specification? You know what? That could be right, actually. Let's take a look. I think it's B. So in this particular case, right, the answer to this was that B in the specs container.image field of the pod specification, that's how you would answer this question. Now, that's question 11, and obviously, as always, we put references down at the bottom. This PDF file will be shared with everybody, but in case you want it now. All right, let's move on to the next question. We're on to question 12. I'll have to take it on the KCNA exam. So we're on to question 12. Let's do it. Oh, that one just gave away the right answer. Hold on. You already saw it, but that's all right. So what's the purpose of labels in Kubernetes? So 1, is it to encrypt communications? 2, is it to organize and select Kubernetes objects? Is it to store application configuration data or to define resource limits for containers? So again, we're in this first domain with KCNA, and so we're getting asked Kubernetes fundamentals questions. If you ever touch Kubernetes, you probably have some idea what the right answer is. So labels typically are used for manipulation and like management of objects inside of Kubernetes. So it's definitely not to encrypt communications between pods. It's definitely not to store application configuration data, which we literally just talked about when we had a question earlier about config maps. And resource limits sounds like it would be something late, like that would say like resource limits, right? And that would usually be, I think, defined in the YAML for the pod. And so in this particular case, I would say that to organize and select Kubernetes objects is absolutely on the mark for labels. So let me paste this in the chat for those who haven't been seeing it. But the answer here, as you saw earlier, was B. Questions or comments before we move on to question 13? Hello, recent joiners. I'm Michael Forster. I'm one of the principal trainers over at KodeKloud, if you don't know me. We're going through the KCNA exam, just running through the first section. Yeah, let me see if I can make this better. Yeah. All right, here we go. So, next question. Which component runs on every worker node in a Kubernetes cluster? Right? This is a fair question. So you have to know the components of Kubernetes. This is definitely part of that particular aspect of knowing Kubernetes. So we just talked earlier about how etcd stores all the configuration data, so that would probably be off the table, to use a phrase. We talked about the API server literally like 2 questions ago. So we know that's for API management, reception, all that stuff. Kubelet. We talked earlier when we were going through some of the distractors about how the kubelet does actually run on the worker nodes. And it actually does do something related to managing the worker nodes. And then there's the kube scheduler, right? Which does what you think it would do. It does scheduling for Kubernetes. And so in this case, I suspect it is C. We're going to do the Jeopardy style. What is kubelet? So we take a look. It is indeed the kubelet. The kubelet is basically the agent that runs along with kubeproxy that helps manage deployment, listens to the scheduler, talks to the API server, reports status, right? It basically, its job is to manage the lifecycle, as it says here, of pods on that node. So basically talks to the API server and gets the specifications and makes sure that what it's running matches what is expected or what is declared to be running. All right. We are now on to question 14. Question 14. I'm wondering if I did not set that up. Sorry, it's my fault. Make sure that's fixed for next time. All right, what is a replica set responsible for? So, interestingly enough, we don't really usually directly manipulate replica sets. On a rare occasion, we will do that, but typically we manage it through deployments, right? And so then what would a replica set be responsible for? So, storing persistent data for applications. We haven't really talked about this, but that's probably not the component, right? Could be close, but it's probably not that component. Replica set sounds like it's something to do with copies, right? Providing network access to pods. If you know anything about it, I have the answer. Ensuring a specified number of pod replicas are running. Well, it's kind of a little bit of a gimme, right? And then managing user permissions in the cluster. Well, that doesn't sound right at all. But the fact that it contains the word replica alone, even if you didn't know just straight off the top of your head that replica sets basically help define the number of pod copies that you're going to run. Oops. Yeah, then you probably know that C would be the answer. Like I said, the KCNA is not that hard, actually. Certainly by way of comparison to the KCA. So here the right answer is actually C. It's a replica set, and its job is basically to define the number of identical pods that you're going to run. I just realized I forgot to paste the question, so how about we do that? Okay, we're on to question 15. All right, so this time I'm going to give you a chance to paste your answer in the chat if you're interested. That's really what we're looking for. So, assuming that I just haven't left the answer sitting right there, which I might have. I apologize. Oh, I did. All right, let's do question 15. What does it mean when a pod is in a pending status? Right? Pending status. What does that mean? So first of all, I wouldn't necessarily say, like, hey, if your relationship is in a pending status, I don't know that I would say that your relationship is successful. So it seems like 1 is kind of out of bounds, right? Doesn't seem like, that would be good. The pod has been accepted by the cluster, but hasn't been scheduled to a node. Interesting. That sounds like it's kind of like an in-between state, like pending, right? The pod has completed its task and is shutting down. Well, that definitely doesn't sound like pending. The pod has failed and cannot be restarted. I feel like I would get a more descriptive error message for that. All right, so while I'm pasting this into chat, what do you think the answer is? What do you all think? Or are you like, this is too easy, Michael? It's insulting for me to even put this in chat. Or is it like, oh, wow, it's actually really hard. I don't really know the answer to that, which means that you're in the right place because we were here to study a little bit, right? All right, so if I were to take my guess, looks like somebody's typing actually. This definitely doesn't look like it, right? This definitely looks like this would be it. Completed task and shutting down doesn't seem like that would be it. Failed, definitely not it, right? So if you look, the correct answer is B, right? So as stated in the solution, right? Well done, Slaw. Is that it's in a pending status. It's been accepted by the cluster. It's in etcd. Specification has been accepted, but the scheduler hasn't like done anything with it yet, right? It could be because there's a problem with the scheduling process. Doesn't have a node to put it on, or there's no nodes available that meet the pod's requirements because you have a taint, a toleration, some kind of affinity, a resource constraint, something along those lines. It just depends, right? Or you've put in like a selector that's like making it very like only if the node equals this, like Windows, for example, would be a good example. All right, let's go to question 16, assuming I can spell the word question. All right, so question 16, assuming that Michael can keep the answer off the page, which he cannot. How do containers within the same pod communicate with each other? So this is kind of interesting because if you have containers that are in the same pod, I know this is going to sound weird, right? But one of the questions I frequently get is that why did they create pods to begin with? Like, why is this the object that they created to host containers? Because the general rule of thumb is that you don't, for example, like if you were running WordPress, which requires some kind of front-end PHP enabled web server, and then some kind of back-end database, which is typically MySQL because that's the default. Wouldn't you just run those together, right? Wouldn't you just run those in the same pod? And why didn't we just stay with containers? Why do we even create the pod? Did we create the pod so that we could like scale things together? But just to say this, you wouldn't put a database and an application in the same pod because you want them to scale independently. Every time you scale your web server, you don't want to add another instance of a database. And if it's a transactional database, you're going to have trouble anyway, because transactional databases usually want one system as the primary writer. Again, modern transactional databases have shifted a lot of that, but you don't want them to scale at the same time. You want them to scale independently. If your web server gets overloaded, scale that. If your application server gets overloaded, scale that. If your database server gets overloaded, scale that, or add more readers if it's a transactional database. There's a bunch of strategies there. I guess my point being is then, why did they create the pod system? What was the purpose of that? Well, the purpose of the pod system was indeed to take a set of containers and scale them together so that you could horizontally scale very easily. But also, like, in the sense that Kubernetes abstracts away storage and networking as much as possible, the idea was to create kind of an isolated environment so that everything in that pod could easily talk to each other as if they were on the same networking stack and as if they had access to the same thing. So when you talk about how they communicate each other, like do they use the DNS system? I mean, they're like right there next to each other and they're sharing the same network stack, right? Now, when I say it's sharing the same network stack, then that makes this appealing, right? Because they are running on the same networking stack. Through a separate service resource, you could do that, but that adds probably an inordinate level of complexity. Plus, you'd have to go out of the pod that you're in order to act. Anyway, you'd have to, it's convoluted, right? And they cannot communicate directly. Well, that just completely defeats what I just said about them being on the same network stack. So in this case, it would probably be B, right? They're going to share the same networking space, right? So they're on different ports, then they can just communicate on different ports. It's not that big of a deal. They are sharing the same network stack in that way. So think of it as, in a sense, like for them, they feel like they're on the same host, if you will. They just need to be on different port numbers. So the rest of that, I think, hopefully is explained pretty well. All right, we're gonna do a few more. We've been here for about 45 minutes, so we only got about 15 minutes left. We're gonna go through a few more questions. And then what we're going to do is we're going to finish out a few Kubernetes fundamentals questions, and then we're going to go to the randomized questions just to give you a feel for the other domains. If you come back next week, just so you're aware, at the same time, we're going to be doing domain 2, and then next week we're going to do domain 3, and then the last week we're going to do domain 4 and 5 together because they're actually pretty tiny. Okay. All right. I apologize for the setup. We'll make sure that's fixed next time. So what is the primary difference between kubectl create and kubectl apply, right? Now that's a good distinction. What is the difference? So it creates for pods only, applies for all resources. That doesn't seem to be applicable, because in general, it seems like all of the commands in Kubernetes apply to all of the objects, or at least to their respective objects, like expose, for example. Create fails if the resource exists. Apply creates or updates the resource. Now, we had an earlier question about kubectl apply, kubectl apply, and in the answer, it said that it's going to create and update the resource. So that seems like that might be in the right direction. Create is faster than apply. Doesn't seem like that's right. There's no difference between them. Well, there probably is a difference. Otherwise, I don't think the commands would exist. In this particular case, I'm going to guess that B, create fails if the resource apply updates or creates the resource, right? And the answer is indeed B. So we're going to put this question in chat. Great answer is B. Any questions or concerns before we move on to the next question? All right. Let's talk about question 18, which is, what information is stored in a secret? Like, what do we store in a secret? Do we store public configuration data like application settings? That doesn't seem right. It's a secret, right? It doesn't seem like we want to make it public. Sensitive data like passwords, tokens, and keys. Now that sounds like a secret. Container images and their metadata. Well, isn't that a container registry? That doesn't make any sense. Network routing rules for the cluster. That doesn't sound right either, right? I would easily guess that it's probably going to be B, right? Sensitive data. And of course, that's what it says, right? Now, my general recommendation is please make sure that you are maybe encrypting that a little harder than what they usually do with the base 64 encryption for secrets. But, you know, that's just me. At least it makes it so you cannot easily see it and just know what it is, right? So, or even if it's recorded, obviously. All right, now we're on to question 19. We're almost finished with our set of 20 questions. Okay, question 19. All right, so again, my answers are up. When you delete a deployment, what happens to the pods that it manages? Okay, so this gets into the understanding about immutable and mutable deployments, right? So pods and the containers inside of them, and containers in general, oddly enough, are basically immutable. You can attach data volumes that have mutability to them, but generally you're not going to change a container. Like if you change the configuration, you're going to redeploy a container. So that container's lifecycle is going to get deleted if you're going to redeploy it, right? And so when you delete a deployment, which is a grouping of pods, including like a replica set, when you delete a deployment, it typically is going to delete everything associated with that deployment, right? So pods are not going to continue to run independently. The pods are deleted along with the deployment. That sounds actually pretty good. Pods are converted to standalone pods. That doesn't sound right, actually, since that is an encapsulation layer for the deployment. Only the pod metadata is deleted. The containers keep running. That sounds a little bit like this, where the pods continue to run independently. That's not what happens. So the answer here is that the pods are deleted along with the deployment. The deployment encapsulates the replica sets in the pods, right? And so when the deployment's deleted, then it's going to delete the rest of it. So correct answer here would definitely be B, right? When you delete a deployment, then that's going to cause everything else to delete. Okay, last question. All right, what's the purpose of the selector field in a service? Okay. Ow. So A is to choose which namespace the service operates in. B is to determine which pods the service should route traffic to. C is to select which ports the service should expose. And D is to specify the service type. Is it cluster IP? Is it node port? Et cetera, et cetera, et cetera, right? And so in this particular case, to choose which namespace the service operates in, I'm trying to remember, like, do we specify a namespace? Is this service tied to a particular namespace? I don't think that it is, actually. B, to determine which pods the service should route traffic to. That sounds kind of right, actually, because the service is supposed to be pointing towards a certain set of pods. How does it know which pods it should be directing to? Does it do it by name? Well, the names change, especially if things are redeployed. So there's probably some kind of label attached to those pods that tells the service, these are the pods that you're going to route to, right? To select which ports the service should expose, I don't think the selector field is used for that because that's part of the specification. And to specify the service type, nope, that's definitely part of the specification. So no, that doesn't make any sense. So if we look here, then the correct answer in this case is actually B, right? So the selector field actually in the specification determines which pods. Let's see, Flamin, you're saying like why sometimes pods get frozen in a terminating state? That's a good question. Most of the time, if I see pods get frozen in a terminated state, it may be because there's some kind of shutdown process. Like, give you an example. If we're deleting a deployment and something is wrong, and for some whatever reason, an API call or whatever didn't go through to delete like the replica set, and it's following an ordered like set of instructions, like the replica set needs to be deleted before the pods can be deleted, as an example. If an API call doesn't go through and that preceding action doesn't happen, then what will happen is that the pods have been told to terminate, but they haven't yet been finalized for whatever reason, or they're trying to unmount storage, or like there's other attached things to the pod, and that API call doesn't go through, and so they're just kind of left hung in a terminating state because the kubelet's trying to let go of things, but whatever preceding action needed to happen or associated action needed to happen, for whatever reason, it's not letting go of like storage, for example, or, you know, I'm trying to think, storage is the most common one I've seen. But yeah, it's usually because an API call has failed inside the cluster. That's rare though. I don't know that I've seen that a whole lot as far as pods get frozen in a terminating state, but it's usually because something associated or upstream is frozen in the API calls. Okay, so in this case, I think we said that B was the right answer, and so I was posting that in the chat. Okay, so that was actually our 20 questions that we were supposed to do. We've only got a few minutes left, so we're going to do a quick speed run. I'm not even going to give you the answers. We're just going to look at the questions, and that's what we're going to do, okay? Oops. Dang it, I keep showing the answer. This was not set up correctly. I apologize. All right. So what is the primary purpose of a taint in Kubernetes? Obviously, like I just showed you the answer, but take your best shot here, right? Is it to attract pods in a specific nodes? Is it to repel pods from being scheduled on specific nodes? Is it to encrypt data on nodes or to monitor node performance, right? Now, if I said that it was an affinity, right, which of these would probably be the answer? What's the primary purpose of affinity? What would be the answer if that was the question? If it was affinity and not taints? Good. Good. All right, let's go on the next one. Oh, almost got that one. All right. So, what probe check? Oh, sorry, which probe type checks if a container is ready to accept traffic? Which is it? Is it startup probe? Is it liveness probe? Is it readiness probe? Or is it health probe? Which one of these checks if a container is ready to accept traffic? Good. I see some of the readiness pose. Good flaming, right? Readiness probe, not the readiness pose. I don't even know what a readiness pose is. Obviously, startups for like, is it started up? Liveness, right? Is liveness the thing? I think liveness. Readiness is actually what we use, right, to check and see if it's ready to take. And then, of course, there's regular health checks, which can be combined. Okay. Question 4. What's the smallable? Okay, so this one we're not even going to show the answer since I keep messing that up. What's the smallest deployable unit in Kubernetes? What do we think it is? That's right. That is constantly said, right? Is that is the smallest deployable unit in Kubernetes. It is the pod. Now, a lot of people think it's the container, but you can have multiple containers inside a pod, usually only one application container. So you can have sidecar containers, operational containers, logging container, all that stuff, right? Okay. Question number 5. What principle is central to cloud native application design? Oof, that's a good one. Let's scroll down a little bit. Okay. Applications should be tightly coupled for better performance. That doesn't sound right. Oh, man. I showed the answer again. Applications should be designed as microservices with loose coupling. Applications should store all data locally on the same server. Applications should avoid using containers. Yeah. So, in Cat, I saw your previous thing. Container alone is not deployable, I guess. A container alone would be deployable. I think the creators of Kubernetes were smart enough to know that you wouldn't just want to deploy an application container, which I think is an incredible foresight. I don't know that I would have thought of that. But they realized that operations might actually have other things they want watching that container, like security sidecars or operational sidecars. Yeah, I know. Yeah. Otherwise, everything needs to be independently scalable. So with this, it's like principles here. I just want to say this is that, avoid using containers doesn't make any sense. Storing all data locally on the same server, that doesn't make any sense either. That decreases resiliency. And then it should be designed as microservices, loose coupling. That makes total sense. That would be the thing. Containers are kind of designed for microservices, are they not? Okay. We're kind of at our last question, so we'll cover this last one. What happens when you delete a pod created by a deployment, right? The pod is permanently removed and not replaced. Oops. The deployment creates a new pod to maintain the desired replica count. All pods in the deployment are deleted, or the deployment is automatically deleted, right? Okay. So, let me just make sure. Okay. Can you all hear me, by the way? Okay, just want to make sure. So when a pod is created by a deployment, so remember, a deployment is an encapsulation device, right? It's an object that basically encapsulates other objects. So it's a workload type, right? So it's going to create pods and replica sets and other things. So if you go in and delete one of the components when it has a known declared state, you can predict its behavior, right? Because this is declarative. So if it's supposed to look a certain way and you delete an object that's in the thing that's supposed to look a certain way, it's going to restore that object, right? If possible. So if you delete a pod, ideally what it's going to do is it's going to create a new pod to maintain the desired count because it knows what its state should be. That's why its deployment has a replica set, right? So it should create a new pod, so the answer should be B. Okay. All right, so for those of you who just joined, that was our hour. And just know that I'll be here next week, and we're going to go over Domain 2. This was recorded. I don't really know exactly how this came out from a recording perspective because it's not doing Discord recording. but here you can see what I see, so you can see all the sausage being made. So I'm gonna try and share the recording, but I'm gonna basically take this PDF and paste it in the chat so everybody can have it if you want to do your own study. But hopefully that gives you a sample for the difficulty level of the KCNA test, which, if you're experienced with Kubernetes and CNCF, it's probably not that hard. If you're brand new, then it's probably going to be like, oh yeah, I'm learning some things. So that's it. So I appreciate you all that joined. Y'all, like, I'm in the southeastern United States, so you can hear me use the southern vernacular. But thank you for joining. So I'll be here next week at 7:30, and we'll go over domain 2, and I'll post the PDF out here shortly so you can study. So yeah, and we're gonna keep this going probably for the rest of the year with maybe a few breaks here and there. So you will see a poll from us about like what would you like for us to focus on. So we can do Kubernetes. I pretty much have every certification. So like I say that it's a very big deal. So we can cover anything from AWS to Azure to GCP. We could even do some of the NVIDIA certifications if you want to do AI. So anyway, we'll put a poll out so you guys will let us know what you want to focus on. But we're gonna do the next 4 weeks on KCNA. So I'll see you next Thursday at about the same time, 7:30 a.m. Eastern United States. I believe that's gonna be 6 on the IST side. So we'll see you next week. All right. Have a good weekend.